How's it going?
Doing great. Welcome to TimescaleDB Twitch stream or live stream. I guess we're streaming on multiple platforms, so we're just live streaming today.
Yeah, that's great. That's great. How does my how do I sound? Is the sound
Everything
okay?
sounds great. Yeah, everything sounds great.
Because I have a little bit of sun over there. Let me get a little bit out of my face. I think that's better.
Good. Looks great. So how are things in Spain today?
Things are pretty good. Very warm weather. I'm in Barcelona, so I know the parts of Spain may be different, but here the weather is great. Things are pretty calm. I'm really excited about the new what we're going to be talking about today, the new launch of our tracing support in Promscale. So yeah, looking forward to this.
So yeah, I mean, for those who don't know, you've recently joined Timescale. So how about you just quickly talk about your role and what you're doing?
Yeah, so I joined Timescale. I think it's a little bit more than 3 months. Well, actually, exactly. I think it was July 12th. So what day is today? 13th. So it's 3 months and 1 day now. Yeah, so I lead. I'm VP of Observability at Timescale, and I'm building with the team a new observability product on top of TimescaleDB. So I work with engineering, the go-to-market organizations, product to build a new offering on top of TimescaleDB to solve observability problems.
That's awesome. And your background, where did you come from?
Yeah, so before joining Timescale, I was at New Relic. So I spent 4.5 years there, more or less. Wow. And so New Relic is a public company that is one of the leaders in the observability space, actually. So I have a lot of background. I come with a lot of background in this space. I really enjoy it. I really love building developer products, and observability in particular combines two of my passions. Let's say one is the developer aspect of it, technical product, but also the analytics, like analyzing large amounts of data and deriving insights from that data.
That's awesome. Great. Well, I think we can go ahead and get started. The reason so why did we launch this week? I mean, obviously it's something we've been starting on, but this week it brings some value to us. Where's your team at?
Yeah, so this week is a big week for the developer community. It's the week where KubeCon, the Cloud Native Computing Foundation, has a flagship event that is KubeCon, the Kubernetes conference. So it's happening this week alongside a lot of co-located events like PromCon, the Prometheus conference as well, happen on Monday. Today is the first day of KubeCon, and KubeCon will run for 3 days, so until the end of the week. And it has become, actually, KubeCon has become one of the largest open source conferences. I think the last one may actually have been, now with COVID is a bit different, but the last one, I think there were maybe 12,000 attendees or something like that.
Oh, man.
So I think it was probably the largest open source conference.
That's awesome.
Worldwide.
That's awesome. Great. Yeah. So we have a team on the ground. This is the first conference for many of them, live conference in, coming on 2 years. I know they're excited to be together. And it's funny, one of my developer advocates, she's recently joined Timescale. Miranda has been doing a lot of good work for us. And she's out there. I said, man, you're actually going to get to meet Timescalers before I have. And I've been here a whole year. I haven't got to meet anyone face-to-face yet, except Miranda. We live actually near one another. But so that's exciting for the team. And man, excited for what's ahead in the new year and what you're about to show. My background is application development. So before I came to Timescale for this kind of developer advocacy work, specifically around databases, because I love data and I love databases, I really spent almost 20 years in app development. And in the last, you coming from New Relic, I mean, at one point, one of my applications, we're a New Relic company, and in .NET, we were able to very easily add a binary in, and magically stuff started showing up. Right, we were able to follow paths through each of our services, see what users were doing, get, observation at all levels of the application, which is great. And so it's just interesting to see where we're coming, and especially with the open source nature of all this, the ability, knowing what we're doing in Timescale behind the scenes, to really start to draw all of this stuff together in a way that's SQL compatible, which is really exciting. So.
Yeah. That's definitely one of the key things we want to offer our users is the ability to query all the telemetry data types. It's not just metrics or just traces, maybe in the future logs, but it's actually all the telemetry data types with SQL. That is a language that, I'd say probably every developer most likely knows SQL.
It is.
And even people outside, the developer world knows SQL, like people in, the data scientists and people doing, analysis on data, they're very used to use SQL. So it's a very, very well-known language, very sophisticated and powerful capabilities. So I'm really, I've been, as I've been onboarding, over this, first 3 months here, I've been quite surprised, because I hit, I knew Neurality, I mean, they have a great offering, but when you were trying to query the data, I saw some limitations, because obviously they built their own database and they built their own language to query that looks similar to SQL, but it doesn't have all of the functions like joins and subqueries and things. Well, subqueries, I think they added recently, but joins, for example, is something that is not available. And then sometimes like things that make your life easier, like running regular expressions to change things as they get projected, in the screen. That with SQL is just so easy, that it's been there. It's really, really powerful. You can do pretty much anything that you can think of is actually possible with SQL, which is great.
It is fun. It's good to watch. Well, let's go ahead and get started. I know you have a lot, to cover about what we're doing and how tracing is being involved. So this is specifically about, I know you're going to talk a little bit about Promscale and what that is and what the offering we've had there over the last, year. There's been an integration with Prometheus for probably about a year and a half, which we then revamped into a fully supported and fully staffed, product within Timescale. And then adding tracing support. So let's go ahead and look at what that is. If you want to share your screen, we can.
Yeah, let me do that. Okay.
And for those of you who are watching, if you have any questions, we are watching chat and so forth, please feel free to ask questions as we go, and we'll do our best to prompt. I'll prompt Ramon so that he can. He can answer questions if we need to as we go. So please feel free to do that and go ahead.
Yeah, so I'm going to go through some slides. I want to talk about tracing. Like first, I want to frame you. Okay, what is tracing, and explain what problems you can solve with tracing. Then we'll talk a little bit about OpenTelemetry, which is a new standard, not just for tracing, also for metrics and logs. And that's is actually that. But for tracing, that's been initially the focus, and they provide a lot of value for collecting traces. Is a standard for instrumentation, so you can collect the data. And then I'll talk about Promscale, what it is briefly, and then we'll jump into how Promscale and OpenTelemetry can really help. At the end of the day, make better software, because one of the main reasons people use observability is obviously to troubleshoot, and there is a problem, I want to make it, I can find maybe a workaround or something to make it work. But at the end of the day, you want to improve that product so it's more reliable, more resilient, more performant. So one of the goals of observability, eventually, after you solve maybe the issues you have in production, is to build software that is that is better. And then I'll be showing a demo.
Awesome.
Yeah, so let's get started. So the first thing, I mentioned, distributed tracing with Promscale and OpenTelemetry. First thing, okay, what is distributed tracing? So the first thing is that distributed tracing started as microservices were being adopted. The challenge is that traditionally, before microservices existed, applications were like large monoliths. That's how they were called. They had all the different layers, like the front end, the data layer, the business logic. Everything was the data, the layer to access the data. Everything was packaged together into one single application. And even today, a lot of very well-known products are still monoliths, and there is organizations have been moving to microservices, but a lot of them are still monoliths, and there is a transition, slow transition in some cases, because it's complex and a lot of work to turn them into microservices. So the reason why people use microservices is because as you decompose your application into smaller pieces, it's a lot easier to release changes, for example. So you can move faster. You can make a change. You can release just one component. You don't have to compile like a big thing or deploy a big thing that maybe takes a lot of time to start and load it. It's a small thing. You can make those changes much faster. So it helps you move faster as well, push code to production faster. Also, if there is an error, it's a lot easier to roll back. It's not going to take minutes or maybe hours to roll it back. It's going to be fast. So, and then also organizationally, as teams, engineering teams become larger and larger, it's a lot easier to manage changes if your architecture is more, decomposed. It also forces you, at the end of the day, forces you to think about providing, APIs and make each of those components fairly independent from the rest. So yeah, as teams grow, there is also an organizational aspect where microservices help. But the thing is that as you decompose that, it really becomes running and operating those systems in production. It becomes a lot more complex, because when there is a request, a request in this case, we have an example. Actually, let's look at the example. So we have a simple example here. That is a very simple example because there are only 4 microservices, which are the 4 boxes that you see here on the left. Right. Typically, a typical application, a small one will probably have tens, and a large one probably hundreds, and maybe in some cases even thousands. For very large applications. And so what happens is that when you as a user, this is a new site. Okay, so the new site has a front end. This is what delivers the HTML content to the user browser. This is what when you open a URL for this site in your browser, the request hits the front-end service. Then the front-end service, to actually build the content of the page, relies on a few other services. The news service, the comment service, and the advertising service. The news service is the one that can collect data from a news database that gets populated, let's say, by the editorial team. They have a separate application, and news that are ready to be published get published into this news database, and the news service reads from there. Then you have the comment service, and the comment service is the one that talks to the comments database. It can write data to the comments database, and it can also read data from the database. And then you have the advertising service, which integrates with a third-party REST API to collect ads to show in the articles. Right. So the thing now is, before you had that, basically the front-end news, comment, and advertising services were probably just one thing. And so you made a request, that thing went through that application, and if there was a problem, you probably were using logs, so you will very quickly see the issue, because all the logs are obviously sequential. They're in the same file. You probably have one ID, that you can use for that specific session, potentially, that you could leverage and just and probably easier to troubleshoot using logs and metrics as well, more at a high level. But here it's different. When you hit, the way this works is that when you hit when you want to read an article, the front-end service, as I was explaining, makes a call to the news service. The news service gets the data from the news database and then calls the comment service so the comment service can give the news service the comments for that article, and then it will call the front-end service, calls the advertising service to retrieve the ads, and then it gets all that together and builds the HTML content. So if there is a problem that, okay, there was an error, the front-end service returned an error. Okay, where did that error happen? I cannot go check just one service and see what the error is, because there are a lot of points. And here again, there are just 4 places where things could go wrong. But imagine if there are tens or hundreds of places where things could be wrong. Like hunting those issues could be a big problem, right. And a lot will require a lot of time. And so that is where tracing comes into play. So here I'm showing this is an example of a tracer. At the top you see the same architecture that I was showing before, and here at the bottom you see an example where I just explained of how a news article, once a user makes a request and retrieves, her browser loads the HTML content, what happens behind the scenes. And so a trace, what it tracks is how the request flows through the different services or the different components that make your application.
Right.
So it will track, that, okay, first we received the display full article. Then it tracks that the front-end service is making a call to the new service. Then the new service makes a call to get the article with comments. That's what it received. That's a request that it received from the front-end service. And so that's what it does. It first goes and queries the database, and it retrieves the article, and then it calls the comment service to get the comments. And so the comment service gets the request from the new service, and then it goes and queries the comment database. So it gets the comments and it returns that up. So here, eventually the front-end service gets the data, through the new service. And then the next thing is building, collecting the ads. So it goes and calls the advertising service, and then the advertising service receives a request. Okay, give me the ads for this article, and then the advertising service will call the third party, the ads provider REST API. It gets, a response. It sends the ads back to the front-end service, and eventually, the front-end service renders the HTML. And so what you see here, that is a trace. That is called a trace, and it's a sequence of segments. Things that happen, operations that happen in order to fulfill that request. And each of those segments are called spans. Okay.
And I'd ask your team this, that was a new term for me. I guess one of the ways that I think it was Beneath had said, the theory is, it's called spans because you're tracking something that happens over a span. Each one of these takes a span of time. And so that's kind of your thread through the whole process of the trace.
That's correct. And so the length, what you see here, the length of each of those bars or each of those spans indicates their duration, how long they took.
Very cool.
So something to keep in mind. And what I show here is actually the most common way, and we'll see that, the most common way traces get represented today. So when you want to see a trace, you actually see this type of representation of a trace that helps you understand, okay, how long, how much time was spent in each span or in each segment, in each operation, and who's calling what. That's the other thing,
Sure.
What's the hierarchy of calls.
That's awesome. Very cool.
So let me go to the next slide. And so traces are very valuable. As I said, when you have a microservice environment, it's really hard. It's very hard to collate that data, together to actually build up an entire request just from logs. And the reason for that is traces do propagate an identifier. It's called the trace ID.
Okay.
That every span is stamped with. So then, you have all the different spans, the data for the different spans, they're stored in a database, and then you can query, okay, give me all the spans for this trace ID. You get all that data, and then you can compose again, the entire trace. The other attribute that is in there that is important, there is a parent span ID, and we'll see that, which, because you have that relationship, I as a span was called by someone, except the original one, right? That is called the root span. The first one doesn't have a parent, but all the other ones have a parent. So the span has a reference, okay, who called me? And with that information, you can actually build this structure.
Very cool.
So traces are very valuable, as I said, because they give you an understanding, what's actually happened. They get all the information together, and you can see relationships between services, who calls what. You can see how many times, how long, each individual operation to fulfill our request takes. And all of that is already organized and as I said, is put together for you.
Gotcha.
However, they've seen very low adoption. And there are three main reasons for that. So the first one is that traces have existed for quite a while, but they're a relatively new data type. For developers that have been used to building monoliths in the past, and that now, or in recent years have transitioned to microservices. They were used to metrics and logs, so they carry using that. But introducing traces is okay. It's a new thing I need to learn, I need to investigate and understand. So that's first. some people did take, and probably a fair amount of people did make the effort. Okay, there is this new data type, it can help us. Let me take a look. But then the challenge is, it required, a high initial investment, because you needed to manually instrument your code so that you could capture those segments, propagate the trace IDs, and all of that. Also, because it's a new data type, it requires a different backend. What you're using for metrics and logs wouldn't work for traces. So you need to set up another backend. Okay, I need to find one. I need to operationalize on it, define alerts. I need to train my team so they know how to use it. And if something goes down, I need to have runbooks so that we can bring it up. So there is that as well. That it's part of making that makes that initial investment higher. And then finally is that, unfortunately, it's been hard to get value from traces. Like, traces is an amazing source of information for identifying all sorts of problems in a microservice environment. Unfortunately, the way that data is exposed, or what people can do with the data today, is fairly limited. You can run some basic filters on things, and you get a list of traces, and then from there you can click on one and visualize it like with a visual like I showed. But you cannot really run queries that aggregate the data, that join data, that maybe correlate metrics and traces, potentially, which, by the way, would require things to be in the same database. For to do it properly, or in a performant way. So anyway, that's the other thing, and so that's why, adoption has been low, unfortunately.
Yeah, I think back over the last couple applications, that I've been with. The last one was a fairly large IoT application, and same deal. We were taking that time to get things broken out into microservices, specifically to try and get even the value. We were at the time, a very Amazon heavy, AWS heavy company. So now we're trying to take our microservices, run them individually, backed by Lambda. You can get a lot of value out of backing them by Lambda, so you can separate, and no one takes anyone down. But that in and of itself was a huge effort. And then trying to say, like, man, exactly as you're describing, we were easily able to identify when things were going wrong, because at the time everything's in one place, running on one server. We can track all that stuff. And this is absolutely a hurdle. It's like, we had tools that were easy to plug into what we had. And now not only are we taking this effort, we believe in the value long-term, but oh my goodness, how do we get that into here? And how do we find the value out of it? It's one thing to spit a bunch of messages, but then what? No one knows how to actually go find this stuff and figure this stuff out. So it hits close to home. That's cool.
Yeah. So anyway, the good thing is that those problems, can be solved today. And there are, two new tools, that can solve with that. One is OpenTelemetry, and the other one is Promscale. So let's talk about them. Let's talk about OpenTelemetry first. So OpenTelemetry is a new instrumentation standard. So instrumentation is what you use to actually, what you add in your code if you want to collect or generate metrics, traces, and logs. Typically, those are the main three data signals.
Okay.
And so up until now, there hasn't been a standard that has had like wide support in the community, from both vendors and cloud providers, as well as end users. So the good thing is that OpenTelemetry is a CNCF project. So it has the CNCF, stamp and backend, which is, a very good thing to drive adoption, also to ensure that the project stays, vendor agnostic, and is not, like the roadmap doesn't go, in a way that it favors potentially, just one player. It tries to be best for the end users. I mentioned this, but it's vendor agnostic, and that is actually really important as well. I'll explain how it works, but basically, it's vendor agnostic because the instrumentation, the data that gets collected, can be sent to any backend. In the past, access to good instrumentation metrics, I think there's been, fairly good coverage in open source, but for tracing, it's been fairly limited. And if you want a better coverage, you actually have to pay for an expensive solution, that will come with some automated instrumentation. But then obviously you're locked into that solution, right? So you cannot you can move to something else, and maybe you're adopting that solution, and you're also using their APIs to generate metrics and maybe logs. OpenTelemetry is trying to change that. It's trying to say, okay, I think we should join forces and build instrumentation together, so everybody has access to the same level of visibility. And then the value is in what you do with the data, what things you can do with the data, what analysis you can build on top of that information. Okay. Another thing that is very special about OpenTelemetry is that it's not just metrics or just traces or just logs. It's actually the three data types, the three main data types for observability. And actually, in the future, they're actually even considering adding other things. I think there are some discussions around profiling, for example, making that part of OpenTelemetry as well. It also defines a protocol and semantic conventions. And that's actually also really important because that helps with interoperability. That protocol, that is called OTLP, the OpenTelemetry protocol, any tool that speaks that protocol can natively integrate with OpenTelemetry. So you can receive data from any OpenTelemetry source. The semantic conventions define things like how to name certain attributes, like, okay, what's the name of, if there is an HTTP request that is instrumented, what's the name of the attribute that collects the result, the result code from the return code from that request. If you don't define that, then, like different people will use different things, and then, okay, you get data, it's sort of a standard, but not really, because the data is not the same. So you have to do a lot of normalizing, of the data in the backend. So anyway, so that's also really good. And then finally, and something, I'll show a little bit how it works for a couple of examples, is they provide instrumentation libraries. So they have SDKs for sure, you can do your own instrumentation, but they also provide libraries that already instrument stuff. In some cases, when possible, automatically, like Java and Node, for example, when are languages that allow you to do bytecode injection, they can actually change the code and automatically instrument it. For other languages like Go, where that is not possible, there are libraries that make the instrumentation a lot easier, but do require a little bit more changes in your code compared to the automated instrumentation library. But anyway, that actually goes and solves one of the three problems that we had with tracing, which is, okay, a lot of manual instrumentation. Well, not anymore, really, because now with OpenTelemetry, you can actually get a lot of things auto-instrumented.
Very cool. If you wouldn't mind, and I know a lot of people, viewing a stream, particularly about Prometheus and so forth, probably know, but CNCF, you just quickly talk about what CNCF is. And
of course, yeah. So CNCF is the Cloud Native Computing Foundation, and it's part of the Linux Foundation, and it's an organization that is veiling or trying to promote a good tool set for building cloud native applications. So Kubernetes, for example, is part of CNCF. Envoy proxy is part of CNCF. Prometheus is part of CNCF. So they're trying to provide stack, a set of products to help, open source products, to help build cloud native applications, which are difficult, to build, as I sort of was explaining, the composing thing, how to get things to communicate properly, retrieve, recover from errors. So
awesome. Yeah, cool. I know that Vineeth has been heavily involved in CNCF projects as well. He's on the Promscale team. I think recently was just something with Promscale, right? He's just gotten some.
Yeah. So Vineeth, who is one of the engineers working on Promscale, he's a contributor to one of the OpenTelemetry projects, in particular the OpenTelemetry Operator project, which is a project to help deploy OpenTelemetry in Kubernetes and manage, the life cycle of the OpenTelemetry instrumentation. Cool. One of the components, the OpenTelemetry collector in particular. So he's recently, I think it was last week, he was, I don't know if promoted is right word, but he achieved maintainer status.
That's right. That's what it was. I remember we talked about it and I saw the announcement on Twitter. So very cool.
Yeah. So we're really
happy. I like it.
Yeah. And we're definitely very committed to this. Like we think OpenTelemetry is great and we want to contribute to it. The same way we also contribute to Prometheus. We believe those are, great open source projects. And, we want to like contribute at least our part to make sure those are successful, can grow and deliver great value to users.
For sure. Oh, that's great. Cool.
Awesome. So this is an example. I provide here an example of how OpenTelemetry works to help explain a little bit some of the concepts. So on the left side, we have a number of services, okay, that are instrumented with OpenTelemetry. So what you have in OpenTelemetry, you have an SDK, and then the SDK uses what they call exporters to get the data to different places. Okay, from with the SDK, you in your application, once you instrument the code with the SDK, or if you use one of those auto instrumentation libraries that leverage the SDK to do instrumentation on your code, you can then plug any number of exporters. Okay, you could have an exporter that sends the data to, if you're doing metrics, you could be sending the data to Prometheus, for example. Or if you trace it, you could send it to 𝗥𝗲𝗀𝗃, which is another, a tool, an open source tool for tracing, because they have exporters. They've built exporters for this. But the more normal way to do this is to use the OpenTelemetry protocol exporter, the OTLP exporter, which is the standard one that is packaged already. It's part of the OpenTelemetry offering, so you don't need to go find anything else. It's part of the standard offering.
Right.
And so the OTLP exporter sends data, the metrics, traces, and logs captured with the SDK. They send those data over OTLP, this OpenTelemetry protocol that I was mentioning before. They send the data to, in this case, an OpenTelemetry collector. Okay. If you have a backend, one of these, for example, you have this backend here that speaks OTLP. I'll explain this in a bit. You can actually also send data directly from this OTLP exporter directly to this. But I recommend you use the OpenTelemetry collector, especially in more like production use cases. Why? Because once you run the OpenTelemetry collector, you can actually more easily manage what you want to do with your telemetry data. You send all your telemetry data to the collector. You can use different types of receivers. Here I show 3, but there are plenty of them to collect data from many different sources. The data goes there, and then you can process it. You can define pipelines in that OpenTelemetry collector to process the data. Do things with it. Like an example would be you want to maybe downsample. So you don't send as much data to the backend. Maybe it costs you money. You want to save space, so maybe there is some data that you filter out. There may be some for some security reasons. There may be security you don't want to. There is some data you don't want to get out of your systems into some third-party provider. So you can drop that data as well. You could be transforming the data, maybe adding additional attributes, to the data as well, enriching it. So that kind of thing. And then finally, you get into the exporters. Okay, so you have receivers that ingest data in many different formats. You have the processor to do something with the data. And then you have exporters that you can use to send the data anywhere. You can use an OTLP exporter, and then any OTLP compliant backend can get the data. Or you can use a number. Again, there are plenty of other exporters. A Kafka exporter, for example. So you can put the data in a Kafka queue, and then from Kafka send it somewhere else. Or there are a bunch. Like you can send it also to Zypkin and 𝗥𝗲𝗀𝗃 if you want. There are also exporters for them. So anyway, the OpenTelemetry collector is this magical piece, that actually helps you manage your telemetry, in a much easier way. So as an example, I didn't mention it, but as an example, if you want to change your, that's where OpenTelemetry also comes into play and is very helpful. If you want to change the tool that you use for observability, you don't need, traditionally, you would have to re-instrument your system with whatever instrumentation works, with you have to re-instrument your application with whatever instrumentation is provided by the tool you want to use. With OpenTelemetry, that's not the case. You instrument once and it's there, and the only thing you decide is later on, typically in the OpenTelemetry collector, where you want to send your data. You can send it to multiple places as well.
Right. Very cool.
Okay, so here's just an example, a very quick example of how you instrument, when there is auto instrumentation is available, how it works. Is it a lot of work? Well, Java, that's the only thing you need to do. You just need to add this -Java agent when the JVM is started. I mean, if you're using Tomcat, you typically add that, inside your startup sh file for Tomcat. But basically, you just need to add this thing. That's it. Download the OpenTelemetry Java agent, and it automatically will instrument a bunch of stuff. You can see they support a lot of already libraries and frameworks, and this is going to be getting better over time because a lot of people are contributing to it.
Oh, for sure. That's really cool.
With Node is a little bit different. Okay, so still not big deal. There is a tracing.js file that you can copy and paste, from the OpenTelemetry documentation. It allows, you can add some parameters there if you want. But basically, you can enable, if you want, all instrumentation that is available in Node. And then if you start your application like this, it will auto-instrument also your JavaScript application. So it's really, there is no reason why you would not adopt this. It's true that you may want to add some custom instrumentation as well for you to get maybe better visibility into specific parts of your code. But just out of the box, you get a lot just by doing this. You just get a lot for free. So,
right. It's like, why not, right? If you can spin up an open source collector to get this stuff and start to see what value you get out of it, why not at least try it, right?
Yeah.
You showed Java Node. Is there I assume there's a list of other.
Yeah, there are many. So you have Java, Node, you have .NET, Go. As I say, Go is a bit different, because you cannot do bytecode injection, but still you also have libraries. It's supported. You have there is Ruby, there is work on PHP. Some of the Python, some of those are more mature than others. There is those communities those projects are evolving differently. But yeah, the idea is to build very broad support for as many languages as possible.
That's awesome. Great.
So if you want more information, you can just go to the OpenTelemetry website. So now let's talk about Promscale. So this is how we define Promscale. Promscale, is an observability backend powered by SQL. And the two key things, if anything, the two key things to retain is that we provide a single storage system. So there's a single database, if you want, for metrics and now traces as well. So metric and traces, there is just one. We plan in the future to also add log support. So you have one single store for the telemetry data types, also metadata. You can use it as a database is based on TimescaleDB, Postgres. So you can also add store other types of data like metadata. So single store, and the other one is that there's a single query language, very powerful because it's SQL. There's also a single one. I mentioned before that typically the data, metrics, logs, and traces get siloed into their own databases. Each database has its own query language, so you have to learn it. You have to operate, through different systems, and there is no way to join. If you want to join data at query time, there is no way to do that, right? So you probably need to build some code. If you want to do that, probably going to be super efficient. But yeah, so those are the two key things. Beyond that, is backed by TimescaleDB and Postgres. Okay, so it's a very robust core. Very extremely reliable. A lot of the solutions built for observability, they don't have such a long history. And it's normal because it has evolved. This space has evolved very rapidly over the last few years. So some of those solutions are not mature. They're great solutions. Don't get me wrong, they're great. It's just you may be missing, if you need them, you may be missing some out-of-the-box features around replication potentially, or backups, things like that, right? That they have been solved, for a very long time in the Postgres, ecosystem. Same for tooling. If you want to integrate other tools, well, those systems they use their own language, for querying them. So you are not going to find the hundreds of tools that integrate with Postgres, and with SQL, to query the data libraries and visualization.
Yeah, we bring this point up often. I think it did drop to number 4 this year, but in the Stack Overflow language, it's always surprising to me. It shouldn't be, but the number 4 language of 2021 or 2020 is SQL, right? It's always at the top. It doesn't matter if you're a developer, if you're a data science person, if you almost everyone at this point in time, it's just such an essential skill to have. And man, now to be able to do this across things like observability is really cool.
Right. So yeah, I think SQL, one single database, for everything. You can query with one language that is very familiar to people, which is SQL. It has a very rock solid foundation. It's built on top of TimescaleDB and Postgres, and then you can integrate it with. It's easy to get started because it's integrated with a ton of stuff. It's integrated with Prometheus. It's integrated with OpenTelemetry. It's integrated with Grafana, with a bunch of other tools as well. So it's very easy to get started. This is just an architecture diagram. So on the left you see this is, by the way, I didn't talk about that, but the architecture of Promscale is actually fairly simple. There is a connector, the Promscale connector, and then there is the database. Some of these other solutions, they are built and maybe have 7-8 microservices that you need to operate. And with Promscale, that's what we just have two. It's the connector and the database. And so you have data gets ingested in the through the connector, and you can get data from Prometheus and also OpenTelemetry, and also thanks to the OpenTelemetry collector, actually, which as I explained acts as this translation layer from a lot of other formats. You can just use the OpenTelemetry collector that then speaks OTLP with Promscale, because we have an OTLP, a native OTLP ingest endpoint now to support traces. Awesome. And then from the connector, you can connect the 𝗥𝗲𝗹𝗲𝘃 UI to the connector. We built a plugin. So the way 𝗥𝗲𝗃 integrates with all the backend, 𝗥𝗲𝗃 is a tool to visualize your traces. Is also a tool, actually, 𝗥𝗲𝗃 does a lot more if you want to, because it is also, they provide some client libraries for instrumentation, and they provide some ingest capabilities and storage. So they have some functions that you could use, but in our case, we only leverage the UI because that's the only piece that we need. And in order for you to show Promscale traces inside 𝗥𝗲𝗃, or in order for us to do that, we needed to build a plugin. So we built a plugin, and we provide an image that has the 𝗥𝗲𝗃 UI and that plugin already packaged. So you don't have to care about that. You just deploy that image, and you get the 𝗥𝗲𝗃 UI working. You can start visualizing your traces in 𝗥𝗲𝗃. Awesome. With Grafana, you can query the data. You can query the data using PromQL. We're 100% PromQL compliant. So no problem with that. You can reuse, if you have any dashboards built with Grafana that use PromQL, you can reuse the same. You don't have to change anything. You have, as I said, we have 100% compatibility there. But you can also use SQL if you want. And I'll show that for tracing, for example, for metrics, you can use PromQL. For tracing, there's no way. I mean, in the open source world, you don't have a way to query traces. In Grafana, there is no tracing data source that you can use for querying traces. The traces that are in 𝗥𝗲𝗃 or that are in potentially Grafana template. You cannot do that. But you can with SQL. You can write queries. So with you can integrate Promscale via SQL with Grafana and query your traces and your metrics as well if you want via SQL. And also, as I said, other tools that speak SQL, there are plenty of them. So lots of integrations there. The only thing I mentioned as well, Grafana has added support. They did, I think it was maybe a year ago, they added, or maybe a little bit more, they added support for visualizing traces. And
right.
And so the way they did it is interesting, because the way they did it is they actually used 𝗥𝗲𝗃. They copied the 𝗥𝗲𝗃 UI, which is good. I mean, open source, 𝗥𝗃𝗃 is open source, so they leverage that. That's great. And what they do is they integrate the query. They can use 𝗥𝗃𝗃 as a data source. Okay, so they actually query directly the 𝗥𝗃𝗃 UI. So that's how today you can also visualize traces in Promscale inside Grafana. You can define a 𝗥𝗃𝗃 data source, and you will be able to show your traces there as well. I'll show that.
Awesome. Nice, very cool.
Okay, so I'm not going to get into a lot of detail on this, but this is the at the top you see the span data model for OpenTelemetry. I'll just mention a few things. One is that they have a name, and that typically is the operation, the name of the operation. Start time and end time. The duration. And then I mentioned it before. They have the parent span ID. Okay, so that this might be there is no parent if you're the root span, the first span. But if you are one of the subsequent spans, you'll have a parent. So this is the field, if you want, that points to the parent span. Then you have a trace ID and a span ID, so identifiers for the entire trace and just for that specific span, a bunch of other information. And then you have things that are actually fairly, a little bit maybe more specific to to OpenTelemetry, you have something called events. And those events, they could be pretty much anything. The two cases where I've seen this used, one is logs. So you can actually add logs inside a span, and those would be logs that occur during the duration of that span. So you have direct correlation. If you see an issue, you can actually go, hey, show me the logs, and then see the specific logs, the things that happen during that span. So you get additional context. Links, and also for events, the other scenario where this is used is when there is an error. The stack trace, more detailed error message, things like that, they get captured as an event as well within the span. Links are, to be honest, I haven't seen them used yet. They have like they're there. It feels like for very special cases. One case that it's mentioned in the documentation is that if you have an operation that is or a service that does batches operations in batches, all the calls to add an element into that batch, before it gets, it actually gets processed, would be a parent span, for that next span, that's the batch processing. But that is not possible because you can only have one parent.
Okay.
So the suggestion is add all those, the operations that call to add a batch into the an element into the batch, add them into the links. It feels like a workaround. So I think they added for flexibility. There are some scenarios that will be hard to track. And then what you have, and that is actually really important, a bunch of key value pairs. This is metadata. These are attributes, metadata that you add about the span. It could be, I mentioned it before, like the status code of an HTTP request. If it was an HTTP request, whether it was 200 or it was 500 or something like that. So you can then visualize it and query it. And at the bottom you have, and I won't go into detail. We have a blog post that we publish on our website. So if you want to learn more about the schema, how we built it and why it's built like this, I suggest that you go read that. But basically, this is the schema where we have the spans, and we have a table, hyper tables. That is a TimescaleDB concept for scalability, so we can ingest faster and query faster. So we have hyper tables for the span links and events, and then we have a bunch of other tables for storing tags and other data, or attributes, key value pairs, and other data. We call attributes tags here because we think first, one is more ergonomics. It's a lot shorter or faster to type tag, and we expect people to be filtering on tags a lot.
Right.
It's a lot faster to type tag than attribute, so we use tag. And also, I think it's a more widespread way of calling this in the observability world. Attribute is fairly generic.
That's great.
So now it's demo time. So I'm gonna be showing some how this works. But before I get into that, let me give you a little bit of context of what I'm demoing. What's the setup of the demo environment. So we're using this. Okay, so this is a microservices application, demo application that was built by Google.
Okay.
So actually, people could experiment, deploy it in Google Cloud, experiment on running microservices, there. Also understanding, how this work and all that. Okay. And they had instrumented those services, but they use let's say previous generation of instrumentation. They use OpenCensus. I think there was 𝗥𝗲𝗀𝗃𝗃, some services instrumented with 𝗥𝗲𝗃. And so we use it. What we do is we use Honeycomb, build did a fork, of that repo, and change the instrumentation to be OpenTelemetry. And so that's what with this. And we could actually have used the other one because through the OpenTelemetry collector, and we have actually done that. We can ingest the telemetry, but the telemetry is not as rich as the telemetry that we get here, because you have auto instrumentation, so there are a bunch of attributes that are calculated that are better. So that is that. And then this is the setup. This is what we deployed for monitoring. We have a tool called TOBS that helps you deploy an entire observability stack for metrics with Prometheus and for tracing with OpenTelemetry, together with Promscale and a bunch of other things, with one single command. Okay, that's everything that you have to do. So we're running that, and that is sort of the architecture of what we're using. So this is running OpenTelemetry components as well as Prometheus, together with Promscale and TimescaleDB for ingesting and storing and querying that data.
Right, and people can, and you probably have this at the end, but people can find out if you're new to Promscale and TOBS, what we're trying to provide to people. You can check out GitHub, you can check out our documentation, docs.timescale.com, and you'll get more information about how to start running this stuff.
Yep, exactly. So yeah, let's go into the demo now.
If anyone, for those of you who are watching, as Ramon gets set up for the demo, if you have any questions, please don't hesitate to put them in whichever platform you are watching the stream on, whether it's YouTube or Twitch, Twitter. We'd love to hear what you have to say and answer any questions you might have.
Yeah, so just one comment before I jump straight into the demo. So this is the Promscale. So Promscale is open source. TOBS is also this tool for deploying an entire observability stack on Kubernetes. It's also open source. I didn't mention that. So the entire demo environment is on Kubernetes. They're open source. You can find them. This is the Promscale repo, and you have here installation instructions. And if you when installing Kubernetes and you want to just try it out, this is the TOBS repo, and it's really easy. Okay, so you just need to do this. It's really very straightforward. You just need to download this thing. So this is install TOBS. Okay, and then here is the instruction to do TOBS install, and that's typically what you would do. Our tracing support is in beta at the moment, so if you want to install all the components for tracing, okay, you have to run this. Okay, so yeah, I think this is because I don't have my Minikube. Just start it quickly.
Love it, Minikube. It's great.
And so that'll get started. Yeah, I don't know how long it takes. Hopefully it doesn't take long. But anyway, you do that, and then you run the this command. And on Kubernetes, there is this command line tool, the CLI called 𝗥𝗲𝗃𝗃 or kubectl. I don't know, people call it different ways. 𝗥𝗲𝗃, I call it. That this TOBS relies on to deploy all the different components on the cluster. Anyway, I'll leave that. Let's not waste time on this now. So let's take a look at the setup. So I'm going to go into Grafana now. And what TOBS does, and by the way, I didn't mention, but TOBS already pre-configures. It deploys Grafana. It will deploy the 𝗥𝗲 UI as well. And it pre-configures everything so it works out of the box. You don't have to configure anything. It's already there, configured. So the way, what it does is, in case you want to do this manually, is it configures 3 data sources.
Okay.
So it configures a data source to query Promscale using PromQL, using a Prometheus data source. And you just need to pass, this is the URL for the Promscale connector inside the Kubernetes cluster. This is the data source to query the data using SQL. And it uses the PostgreSQL because, as I said, PostgreSQL TimescaleDB is built on Postgres, and Promscale is built on TimescaleDB. So we have Postgres, of course. So we can use this same data source to query the data. And this is the URL to the TimescaleDB.
Tell you what, Ramon, would you mind zooming in a little bit on this?
Yeah,
requests. No, you're good. Thank you.
So yeah, so this is the Postgres data source to connect to Promscale and query using SQL. And then you can also create a data source, a 𝗥𝗲 data source, so that Grafana can query traces inside 𝗥𝗲. And when I say query, it's not like you have a query language. We'll see there is a UI. It's a bit limited because you cannot do a lot of things other than filtering traces using some attributes. But you can also specify that. And these data sources are created by default when you use TOBS. You don't have to do anything.
Awesome.
And so let me maybe zoom a little bit. Hopefully that's okay still. And so now let's take a look at some dashboards that I've built. So if we go into the dashboard screen, I created a few dashboards here that we're going to take a look at. So let's start with this one, the service performance one. And so this dashboard is showing all this dashboard is built with SQL, by the way, and this is querying tracing data. Okay, and it's aggregating tracing. That I think that the really important part is that you can see here, these are aggregating the data. It's telling me, okay, how many spans in total. This means basically how many times this method, this operation in the checkout service has been called, how many of those calls return an error, and what is the error rate.
Wow.
Okay? With current solutions, you cannot know what the error rate is, because the only thing you get is just a list of spans. Okay, so and actually this is really important. It's something you want to monitor and you really want to know what's going on. If you 1% error rate in send order, in an e-commerce site, that's what the demo is about.
It's a bad deal, right?
E-commerce site having one every 100 orders. I guess there is the send order confirmation thing that failed. That probably means the person didn't receive an email with what they purchased. That probably translates into customer service, requests, So Absolutely. If you have a lot of volume, that's a lot of requests. You fix this problem, you could actually reduce that, right? But just looking at tracing like that, you will not see this. You really have to query and aggregate the data.
Right. So in the case of the span, is the span itself have an identifier of error, or is that something you've had in the attributes?
No, it has. Yes. So there is an attribute called status code as part of OpenTelemetry that indicates whether there's been that span had an error. If there was an error that prevented the span from successfully completing.
Okay.
And so what happens behind the scenes, we can actually edit this thing.
I was just going to ask for this. Good job. Thank you.
Yes. So this is the query, that we're running. You see, it's a SQL query. It's using the Promscale SQL source, and he's doing a SQL query. He's doing a select on, we're selecting the service name, operation. So first, let me show you. So maybe let's start with the from. That will be easier. The way I build this, there are two ways. I could have built this just in the select clause, but I found it easier for me to do it this way in case I was doing it. So I used a subquery, in this example. And I select, there is a view inside TimescaleDB that we create called span. Okay, so you saw that data model there. Maybe you say, oh, that's very complex. How am I going to query that? Wait, don't worry. You don't have to query the data, the underlying data. We actually provide a view on top of it, so it's much easier to query. And
very cool.
We already organize that and provide some functions and operators to make it easy to query the data. But anyway, so what I'm doing here is I'm selecting, service name is an attribute of a span, which is that a span happened in this service name. The span name I mentioned before, it sort of indicates the operation that is being executed. And then I count this. I can use nifty SQL. I mean, maybe
this is so fun.
These are really cool. You can just do a count star filter on this condition, so I can get all the spans that return an error. That had an error.
Yeah.
And count then the total spans as well, so I can compute the rate there. And then the start times, I'm looking at the last 24 hours. That's what I'm looking at. So I'm looking just at recent errors. So I build that subquery into this data set error summary. And then I select the service name, operation, the spans with errors. So I show all the values here. So how many spans had an error, total spans. And then I do this calculation here, and I use the two chart thing to make it look nicer.
Yeah.
And the screen, I could use Grafana actually to do this as well. They have formatting, but if you run this code in another tool, you would not be able to do that. So I'm doing the conversion here, which again, very cool. SQL has all these amazing, amazing capabilities to process the data and do things with it to make it easier to consume. And then I'm ordering by the error rate. So I'm grouping by service name and operation, and ordering by error rate. So I get those operations that have the highest error rate at the top, basically. That's
very cool. It is so fun to see this come to fruition again, knowing and hearing all the behind the scenes of getting this to this point, but really fun to see how easy it is to take common SQL and get real value out of it quickly. It's very cool.
Yeah. I'm again, I've only been 3 months here, so it's actually really cool to be able to do all those things, because I struggled in the past with those limitations, things, and sometimes the smallest things like this, just this, you want to transform the data so it shows in a way in my dashboard, and I couldn't. So it's
Very
great
cool.
that I can do these things. So this is an example. Here we have another example. I'll just show it quickly. So this is a query, and what I'm doing here, I'm actually calculating percentiles.
But wait a second, not just any percentiles. That would be the TimescaleDB toolkit, approximate percentiles.
That's what I'm using. You could use percentile count as well, which is that Postgres provides, so you can use that. But this is offers better performance, so that's why I'm using this, because it's faster. It introduced a small error. I think it's less than 3% in this case. You can actually measure it. It was less than 3%. So for me, it's fine. That's okay. Not a big deal. But yeah, it's much faster. So that's why I'm using this one here. And basically, I'm calculating percentiles, because when you're looking at performance, you should really be looking at percentiles. You should not be looking at averages.
Absolutely.
Even just the median doesn't really tell you. Okay, like 50% of the requests were maybe were fast. But okay, what about, typically you want to make sure that maybe 95% or 99%, depending on how demanding, your users or customers are within, a certain range, right? So anyway, really important to use percentiles. So this
and I mean, this is just an interesting little bit here is, again, by using tabs, you're getting our latest image, which we make sure the TimescaleDB toolkit's included is that's an additional extension that we're developing with analytic functions for SQL, right? So it's all, we're using the Postgres engine. We're doing the best we can to take advantage of all the efficiencies within the planner. And so there's more and more of these coming. You're going to hear about more in the next few weeks as well, which might help. We have some statistics aggregates and so forth that we're going to be adding in, very similar to this percentile aggregate. So very cool. By using tabs, you get this, which is fun.
That's right. So let me take a look at another example here. So let's look at this tracing analytics dashboard. This is a really interesting one. At least I really like this one, because it's one that is really not as straightforward to do with I guess any other tool. You can do this. I think the heat map is easy, so I just show this. Okay, you can do this type of representation, but let's focus here. So what this is showing is service dependencies. So it's telling me which service is calling other services, and not only that, but it also which service is calling which operation in other services. Why is this important? Imagine that in your microservices environment, you have one of the services is under heavy load. You see, it's receiving, processing 10,000 requests per second. And maybe let's say that this is really high. What's going on? Why? What's the source of that? Well, you don't know, because you have maybe you have tens of services, calling that other service. So I don't know. How do I know? Well, you use tracing and you use SQL, and you can do this because you can easily run a query that will find, as we see here, for example, we see that the get product method in the product catalog service is being called by frontend and checkout. And this is fairly a straightforward example, okay? Because probably frontend will be calling a lot more the get product than the checkout, because a lot more people visit the website that go through the checkout process. But imagine if this was something different. You will very quickly see, and maybe there were 10 other services calling it, but with this, you quickly see, okay, I have my service under heavy load. I just need to go and check the front-end service, because I see in this case is making a ton of requests, and maybe that's anomalous. There's something wrong in here. I'm gonna go check what's going on. So very quickly you can identify, what's the source. Otherwise, I have no idea. I don't know. And so how do you do that? Again, really nice. We use joins, because obviously we have to join the client span. If you want the other one making the request, the span for the service making the request with the span for the service receiving the request. So we join the span table with itself.
Right.
And we check that, okay, that the parent span ID of the server, because remember, I'm on the server. The client makes a request to the server, so the span on the server side will be a child to the span on the client side. So this is what I do. And just in case, I use this condition. This one is important because you could have spans within the same service. Okay, you don't necessarily, a span doesn't need to be, I'm calling a separate service. You could be happening within the same. So I'm saying, okay, the service names need to be different. So because I'm not interested in things happening within the same service at this point, I just want to see inter-service dependencies. And then I use some group by and order by. This is actually really, really cool. Another example, and then we'll jump into showing distributed tracing. This is a query that is showing overall what are the slowest traces in my system.
Okay.
In the last, I think this is looking at the last 6 hours. So we see the slowest one are these ones. So it's not very high, but maybe 2 seconds for me is too much, because maybe maybe it's an internal contract that you have. I want to all requests to, maybe not all, but maybe 99% of the requests to return in less than 1 second.
Right.
So here I'm checking these. You can see, I have the attributes here. But the nice thing here is that I built a link. This is the trace ID. And if you click on that link, you jump straight into the Grafana UI for visualizing that trace.
Oh, man, that's cool.
So you can see, okay, what is the time being spent? I see it's in this in front end get card. Something is going wrong here, because it's a very, that's where I'm spending. All the other stuff is really fast.
Right.
As you can see, this is the span that is consuming most of the time. So I can go and check inside this what's going on. And maybe it's a network, maybe it's a network thing. Maybe there is some network problem, and it's, the request, there is very high latency in network latency in making the request.
That is so cool.
So with that jump, maybe we can show now quickly distributed tracing here. So this is the Grafana UI for distributed tracing. One way to retrieve traces is by pasting a trace ID, which is what I'm using to link the dashboard to this UI. But you can also go here in search and then search for a specific, apply additional filters. Like in this case, maybe let's say, okay, I'm interested in only front end, request to the front end service, and maybe let's say I want to see card checkout requests, and then you can run that query, and that will return a number of spans, and then you can click on a specific span and look at it. Okay, so the thing with this is what I said. It doesn't really let you analyze data. You really need to know what you're looking for, because you just can't just show a list of spans. So you really need to know, maybe you have some tags. You can specify a time duration, when, like a time frame where you want to search for the data. But yeah, it's sort of limited in the amount of filtering aggregation you cannot do. But it solves some problem that it definitely doesn't solve more an overview, more analytical queries, an overview of the system where problems are happening. Okay, this is more, okay, a problem is there. Let me dig deep into one, a specific trace.
Very cool. Oh, I love seeing that.
This is the 𝗥𝗲𝗹𝗲𝗃 UI. I'm not going to demo this because basically it's the same. So you can do the same thing.
Gotcha.
It's the same UI. Something I didn't show is a nice feature that Grafana has is this. Let me close this. They have this feature called the node graph that actually shows all the nodes, in the request. I mentioned before, requests are complex, and you see that tree, and maybe you don't realize how complex they are. But look at this. These are all the individual things that happen in order to fulfill that request. It's a different way of looking at the data.
That's awesome. I love it. It's amazing.
I mean, it's really complicated. That's, microservices. That's what microservices are, and each of those things, in this case, it's a service. It's a request to a separate service. Anything could break in here. There are many things that could break.
Man, I love it. Yeah, I had no idea all this stuff existed. So these dashboards are created, ready to go when you use the TOBS integration?
Not at the moment. So we'll provide the JSON maybe for now in the repository, and they will be integrated later on. Like we plan to provide some of the dashboard that people can use.
Okay.
But at the moment, I've set them up manually in this environment.
Sounds great. Yeah, that's what the community, the process is for, right?
Right. Exactly.
Very cool. Well, this is awesome. I'd say knowing, again, your experience with New Relic and others, just knowing the various tool chains that have been available, particularly in the monolithic space over the last many years, and seeing how we can start to make headway into that. It's really fun. I had no idea that you could visualize some of these things. Seeing that SQL, man, I hope anyone who watches this later, as you guys are doing more and more effort, I know the team is creating, as you said, we have a view to try and help make that data more accessible. But there's going to be more, right? We'll come up with more and better ways using features, both within Postgres and within Timescale, to make that data really easily accessible. That is so cool to see. Just finally, for me, someone who loves SQL, loves the database, loves relational data in that way, to not have to learn a new dialect of a new thing to get the same benefit, whether it's New Relic, whether it was Splunk, whether, everyone had their little bit of thing to try and get the value. Like, oh man, I could just join the things together now, right? It's so funny to me, Ramon, when you read some of the articles of Timescale and why Mike and Ajay really had a vision for this company and using Postgres as the basis for so much of this, it was for that exact problem, right? I have all of this data that has value, but it's in different places, and most of it is time series. And so really seeing that come to fruition in a product like Promscale with tracing, it's really cool. For me, it's really cool to see.
Yeah, no, it's really nice. And I think we're just scraping the surface. Like we're just in beta, just released this. And I think working with our user community, we're going to find new ways, that the data could be used, and maybe new things that we can add to the product, as you say, to make some analysis or exploration easier, or maybe in some cases even possible, right? So it's I've been playing with this for the last few weeks, and I've really enjoyed it. It's been a lot of fun, to be able, again, as I said, to use SQL
for sure
to query observability data. I was not used to that, and oh man, it's great.
It's a whole new world. That's awesome. Ramon, this has been really excellent. I appreciate your effort putting this together. I've learned a lot, even just in this hour, even though we've been talking about this for a week or two, just seeing more and more about where we're at. I'm excited. The team's out in California at KubeCon and PromCon over the last few days. Man, I can't wait to see where this goes. As a community, if we really encourage you to give this a try. If you haven't tried Promscale before, if this is interesting, if you see a opportunity within your application, within your stack, to start to do this, please go to GitHub, download. We showed you how easy it is to get TOBS started, which opens up, these endpoints for you to start to push data into. We, as Ramon said, will be making things available over time through the repo. Even hopefully a little bit deeper tutorial you'll find in our documentation over the next few months, using maybe like this Google application as a first way to get started, so you can try it yourself. But please try it out, give us feedback. All of these teams are really open, and I'll put this on the screen again. If you haven't, please join our Slack channel. All right, we have a Timescale Slack community. Really encourage you to join if you haven't. There is a Promscale channel there that the team is often watching and involved with. There's a number of other people within the Timescale company and family at large, community that really try and help one another. So please do that. Join the Slack community, go follow our docs, and give us feedback. Have that conversation within GitHub, whether it be with issues or discussions, help us understand how we can provide that value. So anything else you want to add before we're done?
No, I mean, well, maybe just one thing. So join. I mean, if you want to try the product, or you give the product a try, by all means, join our Slack community. We're very active there. So if you join the Timescale community, TimescaleDB community, there is a Slack channel for Promscale. If you have any questions, drop there, or any feedback, even also saying, yeah, this is great. We love hearing about that as well. So
totally agree.
Like it.
That's awesome. All right. There was one question I'm just seeing here. Let me just read it real quick. Yeah, so I think the one question, this is interesting. So Tom, if you're still watching here, there's one thing we haven't talked about a lot yet. Please drop on the Slack. That's great. Do that. We can help you out. One thing we started to look at earlier. So as you saw, Tobbs, right? We start Promscale, which is the connector with a database in the back end and so forth. We actually have both a Prometheus available, push. My brain is not picking it up at the moment. An integration that you can push data into Promscale as a Prometheus endpoint. And we also have our own Promscale endpoint to push data into. It can become a data store for IoT data. Like you can create your own channels and push data into it. We're actually doing that in other scenarios. So it is an opportunity, right? If you know Prometheus, you can do that. That was basically the question. If I have an IoT app on something like an Arduino, can I use, I think that's what you're asking. Can I use Promscale as almost like a data backend? And the answer is absolutely, you can. And then you get the value of Timescale and so forth on top of it. Cool. Well, Ramon, it's been great. I appreciate your time, all that you've put together here, and can't wait to hear more about what others are doing.
Yeah, thanks a lot. Thanks for having me. Really enjoyed it.
Awesome.
Okay, take care. Bye-bye.
Bye-bye.